All right, so like I say, please let me use red and use some other colors, please. Okay, so for this, so you, okay, please remember this. Okay, there is one thing probably you are not used to. That's why you take it for granted. Okay, meaning over here they ask you for the square root of k, right? So over here, your first step is correct. So you show that, okay, you want to square root this item, and when you square root this item, right? So there are two ways to do this. So I show you my way first. So I use a dot to represent the times. So in fact, this, what you can do is when you square root these two, you are actually square rooting them individually. Okay, so you square root these two numbers with powers. So what you need to find is actually you square root individually. So you square root the 2 to the power of 6. Then here's the times, right? So it's the times in between. So you square root the 7 to the power of 2. And then now over here, you will get 2 to the power of 3 if you use your calculator. And then you get 7. And then after that is 8 times 7. And then you have 56. Okay, so this is the answer. And by the way, they want the positive square root. Okay, they want the positive square root. Okay, why this question they ask for positive square root? Because let me show you another question. Let me show you another question. I'm going to use a blank page here. So what if you have x squared equals to 64? So if your x squared is equal to 64, so in fact you should end up with two answers. X equal to 8 or x equals to minus 8. Why? By the way, a lot of students, they missed out this. A lot of students, they missed out the negative 8. Why? Why both 8 and minus 8, they are the answers? Do you know why? No. Okay, probably you understand why, but this is not the reason why you get negative 8 as the answer. Let me tell you why. So for this kind of question, right, like I say, when it comes to secondary school, it's very easy. You can always test your answer. And see if you can get the question. Okay, so you have 8, so you can put this back. So 8 squared. So 8 squared is 64, right? Next, you test for your negative 8. So negative 8. Okay, by the way, over here is very important. Okay, negative 8 here, you need to put a bracket. Okay, without a bracket, you are not going to get 64. Without a bracket, what you're going to get if you don't put a bracket there? Without a bracket, you will get negative 64. Then you must be wondering, hey, I thought you say x equals to negative 8 is the answer, but over here I get negative 64. So negative 8 is not the answer, right? Some students, they argue with, they have this argument like, no, negative 8 is not the answer, because you see negative 8 squared is equal to negative 64. Negative 64 is not 64 here. So one of the mistakes for this is you have to put a bracket. Do you know why you need to put a bracket? Okay, you can reason this way. Yep, you can reason this way. Okay, so what this x squared equals to 64 means is, can you clear your handwriting first, please? Okay, good, thank you. So this x squared equals 64. So x squared equals to 64. If you write it out, it should be x times x equals to 64. Okay, that's one way to write this. The other way, so this is one way to write it out. The other way to write it out is you have your x and then you square it, then it goes to 64. So what it means is, let's say if your x in this case is negative 8. If your x is equal to negative 8, right? So what you need to do is, if you use this, the first option. So you will get negative 8 times negative 8. So negative 8 times negative 8, like you say, negative, negative, positive. 8 times 8, 64. So you will get positive 64. Okay, let's do it for the second option. For the second option, right, can you see that they want to square the x, okay? They want to square the x. So if you put negative 8 to the power of 2, what's wrong with this? Compared to this x squared, what's wrong with this? Or is there anything wrong? Okay, yes, you are right. So what you are trying to do here is, okay, if you write negative 8 square, right? So let's say you never put the bracket. You write negative 8 square, right? What you are actually doing is you only square the 8, okay? Which is not what you want. They say x is negative 8, right? They say x is negative 8, okay? They say x is negative 8. So, but when you write negative 8 square. So over here, you only square the 8, which is not right. The question wants you to square the x. The question wants you to square the x. Can you see? They want you to square the x. So let's say if your x is negative 64, example, you have to square this negative 64 by putting a bracket there. Without the bracket, you are not squaring the 60. Without the bracket, you only square the 64. With the bracket, you square the negative 64. So are you clear? So this step is so important. A lot of students, they make mistake. Okay? So next time, if you have a negative number for x, so you better put a bracket there. Because without a bracket, you are not squaring the negative 8. You are squaring the 8, which is not what the question wants. So you want to square the negative 8. That's why you need to put a bracket. So once you put a bracket, you key this into your calculator, you should be able to get your 64. That's why negative 8 and 8 is an answer. So this is also an answer. Okay, so when do you have two answers? And when do you have just one answer? Any idea? No idea. Okay, good. So if you have done enough of practice, then you should be able to know the pattern or the trend. Okay, so there is this rule of thumb, means a general rule of thumb. If you have x to power even power, so x to power 4, okay, then equals to 64. So this 4, so 4 is a even power. Okay, so generally, right, when you have 4, when you have an even power, right, you tend to have two answers. You can test. Can you test it out for me? Am I right? No, I think 64. I think it is 4. 4 and negative 4. By the way, please use a calculator. Yeah. Okay. Is it 4? Okay, 4 times 4 times 4 times 4. Oh no, not 4. Sorry. Over here should be 16. I'm so sorry about it. So with 16 is 2. Yeah. Can you help me check? Is the answer 2 and negative 2? Hello? Are you checking? Oh. Okay, good. So have you checked for negative 2 as well? Okay, good. So like I say, you can always check, okay, like 2 to the power 4 equals to 16. And then the other one you check is negative 2. Please give it a bracket. But only when you give it a bracket, you go and power for the negative 2. Okay, if without the bracket, you power for the 2 only. Okay, so remember the bracket. So you get 16. So that's why you get 2 answers in this case. So like I say, if you get an even power, right? If you get an even power, in this case, 4 is an even power. So generally, you end up with 2 answers. Okay. What about just odd power? X to the power 3 equals to 27. So if it's an odd power, so 3 is an odd power. So just one answer. So x equals to 3. Okay. And you can test it. -3 doesn't work. Okay. Negative 3 doesn't work. I mean x equal to 3 only. X equal to -3 cannot work. Okay. If your answer is -3, so -3, you will end up with -27. So, but I say, but over here is 27, right? So that's why you only have one answer. So for odd power, one answer. For even power, 2 answers. Are you clear? Okay, good. So this is something you have to bear in mind. If not, you will get it wrong. Okay, good. Next question. Cube root. So now you can do the cube root. Can you do a cube root on the side here? Let me erase. Can you use a different color? Like? Okay, yeah. Good. First step, very good. You introduce a very good. So just bear in mind over here. This is a odd. This is a odd. This is called odd root. So odd root. So you end up with one answer. If it's an even root, if it's an even root, then you better double check. Are you clear? Okay, now it's good. Okay, so yeah, I see no problem. Okay, by the way, when you write this, right, it's better you extend it out until it covers the cube here. Okay, if you don't cover the cube, right, it's wrong. What I'm trying to say is, what if you have like this? So you start right here, right? Then you times 5. So what this means, this whole thing means is basically you just want to do square root 6 times 5. Okay, so if you want to do square root the whole thing, you better cover everything. Okay, so please be very careful about this. So you better cover everything. Okay, so it's square root 30. Okay, so square root 30, maybe probably you can answer the question in 2 decimal places, or 3 significant figure. You should remember how to get 3 significant figure. Can you help me out? Square root 30, what's the answer? Without approximation first. Square root 30, what's the answer? Without approximation. You can write it here, yeah. 5. So nice. Without approximation. So what is the longs like? Okay, 5.47. Okay, good enough. Okay, so basically over here, right? If you look at this, okay, so for 2 decimal places, should be 5.48. Why? Because this is your first, this is your second decimal place. So you look at this. So it's 7, which is bigger or equal to 5. So you add 1. I mean your 7 here, you add 1 to it. That's why you end up with 5.48 for 2 decimal places. So for 3 significant figures, do you still remember how to do 3 significant figure or not? You remember or not? Okay, good. So for 3 significant figure, this is your first, this is your second, this is your third. Why this is your first? Because this is non-zero. So if it's non-zero, it's my first. So therefore, you look at this also. So 7 is more or equal to 5. So you give it 1 here. 1, like so 1 to the 7. So you end up with 5.48 as well for 3 significant. So they are both 5.48. So you need to write down to 2 decimal places, short form, or 5.48, 3 significant figure. So which one you should take? Like which one of 2.2 decimal places or 3 significant figure, which one you take, right? It depends on the instructions. The instructions you read from your paper. Okay, so you read your instruction. Okay, good. So please clear your handwriting. You attempt question 6. By the way, question 6 is more advanced and more interesting. Okay, good. Question 6. Please do it somewhere here. Yeah, good. Yeah. So the answer is LCM. Is it LCM? Yeah, go ahead. What's the LCM? Do you still remember the two tips to get LCM? Okay, so for LCM, right? Okay, so since you put your LCM in index notation, okay, so let's not figure out this first. So how do you find LCM? The LCM is, okay, let me just give you the 2 tips for HCF and LCM. Okay, what I remember is the first tip is always something to do with the factors. So for LCM is all factors. For HCF is shared factors. So the second tip I give you is something to do with the power. So for LCM, right, is the highest power. So lowest common multiple, L, so you use the highest. For highest common factor, H, you use the lowest. Okay, so with this, so for HCF is shared factors, lowest power. For LCM is all factors and highest power. And it looks to me you have remembered this. Okay, so you pick, okay, what do we have here? You have 2, you have 3, you have 5, you have 7, and you also have 11. So it's 2, 3, 5, 7, 11. Okay, 2, 3, 5, 7, 11. And then you pick the highest power for all of this. Okay, so 2, 6. Good. 7, 2. Okay, good. 3, 5. Good. So 5, 2, and 3, you choose 3. Very good. 11. Okay, good. So now, so what's the answer? Can you punch your calculator, and what's your answer after multiply all this together? 10 to the. So can I ask you a question? Your answer looks like this. Do you think this answer makes sense? I mean, just want to have a logical thinking of this answer. Do you think this answer is reasonable? Or should we do Hcf instead? Should we do Hcf instead? What do you think? Yep, smallest. Yes, I know. So smaller. Okay. So you don't. Okay. What I'm trying to say is you don't get misled by the word smallest here. Okay. Smallest doesn't mean lowest common multiple. Okay. Biggest doesn't mean highest common factor. Okay. So this is the question, right? I would like to refer back to can you erase your handwriting first, please? So I have my lesson with. Can you erase your handwriting first? I have a lesson with Yu Xing on here. Let me go to the solution folder first. Where shall I save it? Okay, let me save it here. Extract. So it's here. Okay, let's look at one of her school's papers. Okay, this is the one, right? Yeah, this question. Okay, so over here, right? If you look at this, so question 7. Can you see question 7? Hello, can you see question 7? No response. Hello. Hello, are you there? Okay, funny thing. Hello, my student, are you there? Okay, good. So, okay, good. Look at question 7. Question 7, you have these 3 numbers. And then the prime factorization is given. And then they say find the smallest non-zero whole number that's divisible. Okay, so divisible by these 3. Okay, good. So what they have done, they're actually finding the LCM. Okay, so the technique for finding LCM, I think you already know it. So the answer is this. So yeah, so this is the answer. So how they allocate the marks, you need to show this step, and then after that you need to show this step. So you need, remember, 2 marks you need to show working. No workings, you get penalized. Okay, so let's come back to our question. So over here, right, they want to find the smallest. So yeah, so we need to find the LCM. Okay, so once we have found the LCM, okay, in index notation, so then you get it into that format. I remember it's 1 point something times 10 to the power of 10, right? Something like that, right? Okay, so unless the question says index notation, okay, if not, you have to, so meaning this one is index notation, question 7. This is index notations. This is the answer. So you need to read the question, what they want. Do they want index notation or do they want answer? Are you clear? Before we proceed. Hello? Okay, good. Okay, clear your handwriting. Then next. So you have finished this. Next one. Given that this. So you can proceed to do given that k times a already. So I'm going to clear this for you. Yep, you should be doing this part. Go ahead. I don't see any response. No response. Is it the internet problem or what? Network a bit slow? Okay, good. Now I start to see. So you think the smallest A is 7. So you need to show your so you need to show your working anyway. But anyway, so how do you show the working? So basically you just write this. So your K, you replace your K with 2 to the power of 6 times 7 to the power of 2. And then you need to times A. And then it says it must be a perfect cube. What does that mean? So that means it can be cube rooted, right? So you just ask yourself, times means what? Times means give. You want to give extra. You want to give some numbers. You want to give some numbers to this so that it can be cube rooted. Okay, so the question you ask yourself is very simple. Do you need to give any 2 or not? So you just write down 2 to the power of 6 over, cube root the 2 to the power of 6. I think you get 2 to the power of 2. So that means this thing can be cube rooted. So you don't have to give it any 2. So no need. I don't need to give it a 2. Okay. So now test for the second one, which is this. So cube root 7 to the power of 2. And you know that 3 and 2, you need to give it a 7. Right? So you give it a 7. That's why your A contains 7 only in this case. Okay. So the answer is correct. 7 is correct. Okay. Good. Next. Given that. This one. So you put your answer here, okay? So this is for you to do your working. So your answer is three to the power of 2. And that's it. Times 5. That's it. So your answer is 3 to the power of 2 times 5. Then 45. Okay. By the way, over here they never say index notation or they never say index notation, right? So you are supposed to give the final answer. Okay. Let's work it out. So over here you have 3 to the power of 5 and then 5 to the power of 2, and you need to divide by a b such that it can be cube rooted. Perfect cube means cube rooted. Perfect square, square rooted. Okay, good. Now, so divide. Over here is divide. Divide means what? Remove. Okay, just now times means give. Now you want to remove. Okay, so that means basically you want to remove such that you can keep root. So test for the first one. So how many trees you need to remove in order to be cube rooted? I think you need to remove 2 of them. So I should put below. So you can actually do it like this. So you start with 5 trees. You start with 5 trees. So in order to cube root this one, you need to get rid of 2 trees. Okay, so you get rid of 2 trees, so you end up with 3 trees. Therefore, you can cube root. So your B consists of 2 trees. Okay, that's your first step. Next, you test for the 5 to the power of square. So you have cube root here and 5 to the power of 2. So you ask yourself how many 5 you need to get rid of so that you can cube root it. So your answer is just 1 5. Let's test. You can put 5 square in 5 times 5. So you need to remove, basically you need to remove, not give, don't give, remove. So you remove 1 5. Do you think that is enough? If you remove 1 5, okay, you can test. So you remove 1 5, you will end up with cube root 5, and you still cannot cube root the 5, right? So that means you have to remove another 5. So once you remove another 5, you have what? You have cube root 1 left, and cube root 1, you get 1. So basically you need to remove 2 trees and 2 5 in this case. So the answer will be 5 times 40, 9 times 25. So which is 2 to 5. Are you clear? Are you clear? Okay, good. So when you times, right, is you give. How many you can give? Over here, divide means you remove. Okay, you remove each until you can cube root it. Over here, we're talking about perfect cube. Okay? Can? Okay, next, last one. KLM, a perfect square. Yeah. So can you erase your handwriting first? Yeah, thank you. So for this one is 3 to the power of 2, 5 to the power of 2, so it's 2 to 5. Please use a calculator. So for this one, Hmm. 2 to the power of 6 times 3 to the power of 5. Okay. Okay. So basically, Okay, I think you have no problem answering no lah, huh? But how do you explain your answer? So probably just a bit of English, okay, a bit of English. So I don't know. Let's work it out. So let's say you have 2 to the power of 6, 3 to the power of 5, and then 5 to the power of 5. Yep, very good. So it's 7 to the power of 2 times 11 to the power of 2. So you just perfect square means square rooted. So basically the question asks whether this one can be square rooted or not. So you can see that this one can be square rooted, but 3 and 5 cannot be square rooted, right? And the rest can be square. I mean, this one can, this one can, this one also can. And then 3 to the power of 5 and 5 to the power of 5 cannot. So you just show this to tell that, oh, or you can use your calculator and tell them what's your answer. I mean, you just use your calculator to times all this and then give you a square root, and then you end up with a not a whole number. Not a whole number. So if it's not a whole number, that means it can't be square rooted. Okay? Okay? So either way. Alright? Alright? So basically, right, the meaning of a perfect cube or perfect square, right? So basically, you go and cube root. In this case, it's cube root, you end up with a whole number. And cube root, you end up with a whole number. Over here, you square root, you end up with a whole number. So that means that means this can be cube rooted or square rooted. If it's not whole number, that means it cannot be. Okay, are you clear? Are you clear before we proceed? Okay, good. Next. All right, this question. Question 1. Consider the 7 numbers stated below. Yes. Yeah. So this question, they test you what? They test you the definition of integers, prime number, irrational numbers. Yeah. Can you do it? While I am cleaning up so that you have white space to work it out. Irrational numbers. Last one, part 3. Okay, good. Let's look at this. Okay, so before we decide what these numbers are, right? I think it's better for us to look at the map. Okay, our mathematics universe, if you still remember. Okay, so in the mathematics universe, basically we have real numbers, right? And then inside real numbers, what do we have? We have integers. Oh, sorry, no, not so fast. We have rational numbers first. We have rational numbers, and then we have irrational number. Okay, we have irrational numbers. So for irrational numbers, do you still remember what are irrational numbers? Irrational numbers are numbers that you cannot express as a fraction. So example, square root 42. So it's indefinite, right? And then is pi an irrational number? Can you check the definition? I also have it here. Let me launch my note. Can you check your note also? What are irrational numbers? So where is it? Are you checking your files? Like what are irrational numbers? Let me do a search. That's funny. Set one. Here. Over here. Can you still remember this map? Can you erase your handwriting first, please? Oh no, don't erase your handwriting, because you erase you can. Okay, so if you look at this map, right? The real numbers, then you have irrational number. Irrational number pi is inside irrational numbers. Can you see it? Okay, so irrational numbers, you have square root 42 pi. Then for rational numbers, I think you can break it. You can break rational numbers further down to what? To integers and what? Fractions, right? And then you need to break it down further. Integers, you can break it down to positive integer, and then you have 0, and then you have negative integers. Okay? Okay, good. So with this map, then only you attempt this question. Are you clear? Never try to do this question without this map. Always put out the map first. Do you know why? Once you have put out the map, once you have put out this map, if you consider this a map, I call it a mind map. So if you have put out this mind map, what you need to do is you just ask yourself, 1, where your 1 belongs to. So 1 is a positive number, so positive integer. Okay, so 1 integers. Okay. Oh, by the way, positive integer is also integer. Are you clear? Then next, you ask yourself, pi over 11. So pi is inside irrational number. So pi over 11 is irrational numbers. Okay. So always have the map out first. But of course, you must kind of like memorize the map. I think it's not hard, right? Get the real number, rational, irrational. Irrational, they are pretty easy. Okay, and then once you have the rational, it's also very easy, integer and fractions. And then you just go down further for the integers. So please remember the mind map here. Okay, you need it for tomorrow. Square root 43. You have to figure out square root 43. Are you getting a non-stop numbers? I think so. So square root 43 is irrational. Next, negative 7. So negative 7 is under negative integer. So I should put it here. So it's very tricky. Okay. Or they want to fool you and you get fooled this time. Okay. So don't get fooled next time. Then now put your 31 here. Prime numbers. Prime number, very simple. Must have 2 factors. 1 and itself. So 1 is not, 这个也不是 no. Negative, definitely no. 31, yes, so it's 31. Are you clear? Are you clear how you do this question? Okay. The most important thing is a lot of students, they go and do it without the map. When they go and do it without the map, it's very easy to get it wrong. Okay. It's very easy to get it right if you have the map out. Okay. So tonight, go back, just memorize the map. Okay. If you need it, you can actually take a screenshot of this. While you can you erase your handwriting? This yeah. Can you erase your handwriting now? Yeah. So if you need it, probably you can actually take a screenshot of this. I mean this one, real numbers, this universe. I think this one gives you a very good map for you to somehow memorize. Okay, I'll give you 3 seconds. 1, 2, 3. Okay, good. So I will go back to the questions. Okay, next, express. So basically you have this 4 significant figures. Okay, I will let you do it first. Question 2. So ABC. Yeah, continue. I will let you finish ABC first. Then I just one shot, I will clear all. So this is your A. Okay, let's look at it together. This one 0.010199. So you have to be extra careful. For significant figure. So for significant figure, so you need to count. So this is not your first because it's first has to be non-zero. So this is not the first. This is also 0, so it's not 0. So not first. So the first start from here. Second, third, fourth. So if you have the fourth here, you look at the one after that. Then you ask yourself, so it's more than 5 or equal to 5, right? So you give it a 1 here, right? You give it a 1 here, 9 plus 1. So you should end up with 1, 0, 2, 0. So it should be this. How do you get this? This is 1, 2, 3, 4, 5. This is 5 significant figure already. And you did not even change this. You did not even change this at all. Do you understand significant figure? You don't look like you understand significant figure. Then how do you end up with this 0.0101199? What is 5, right? 5 significant figure. 1, that's, I don't know. Huh? You don't know? You don't know how to get it. It's more worrying. You don't know. It's more worrying. If you know, it's less worrying. You don't know, it's more worrying. Okay? So always ask yourself, which one is the first? So 0, no. 0, no. For significant figure, the first non-zero, the first non-zero is the first significant figure. That's why you start from 1 here. That's why I say 1, the first one is here. So this is the second one, the third one, the fourth one. So they want 4. So you look at the fifth. So the fifth is bigger or equal to 5. So you give it a 1 to the 9. So you give it a 1 to the 9, so you end up with this. Okay? So this is the answer for this. Next, 30 seconds is a percentage of 5 hours. So 36 seconds, 5 hours, you convert the hours first. So times 60, that is to minutes. Times 60 again, that is to seconds. So this is 300. Okay, I highly recommend you to use a calculator if you are allowed to use a calculator. Okay, don't use your brain power too much. You're going to exhaust your brain power. Okay, so let me just quickly 336 divided by 18000. So you should get 0.002. So as a percentage, you need to put it as a percentage. So times 100. So it's 0.2%. Okay, your answer is correct. Next, last, as a fraction in its lowest term. So 1.05%. So how do you get it to percent? You give it, so you divide by 100, right? So you divide by 100, then after that, you increase 100 here. You times 100 here, then you times 100 below. So you end up with 10,000 below. Then I highly recommend you to use a calculator, okay? So what do you have? You divide by a 5. Let me see. Yeah, you divide by a 5, correct. You divide by a 5 here, you divide by a 5 here, you end up with 21, and then, yes. By the way, the answer must be simplest form, yeah. Are you clear? Cannot. Okay. If you are okay, then we can stop for the first half, and we'll go to the second half later on. Okay, we'll stop for a brief 5-minute break. Okay, see you in a while. Yeah, I'm back. Let me know when you're back. All right. So yeah, we were talking about question 2, and we are done with question 2, and now question 3. Question 3. Arrange in descending orders. So I will pass to you to do question 3. Okay, so for this question I think should be very simple, especially if you have a calculator. But the only thing you need to take note is you need to understand the thing with the dot. Okay, over here they have the dot. So what it means by having a dot above. Okay, so to rank numbers, so let's assign this is the first, this is the second, this is the third, number is fourth. I'm not saying the first is the smallest or the biggest. Descending, what is the meaning of descending? Descending means big to small. Okay, downtrend. That's called descending order. Okay, so to compare numbers, so it's always very easy if you can express this in decimal number. So the first one, 0.9 with a dot above, what this means is 0.9 and then the 9 repeats itself non-stop. Okay, so it's going to be non-stop. So I will just stop at the 6th, okay, the 6th digit. Then next one, which is 0.909 with 2 dots above. What this means is 909 and then 909 repeat itself, and then 909 repeat itself non-stop. Okay, next 99%. So 99% is simple. We all know what is 99%. It's 0.99. Okay, so I think there is a better way to do this is you better align. So over here, I think my numbers are not aligned. So I better align it. Because later I'm going to compare, you know. If I don't align it properly, later compare, I can't compare properly. So it's better for me to align them. Align them, okay? Okay, now fourth. So you have to use your calculator for the fourth one. 10 divided by 11. So I'm going to use a calculator here. 10 over 11. So it's 0.909090. Okay, good. Okay, so with this, I think you can see that the biggest, so looks like, okay, all start with 0, and then all 9, then now comes the part where they are different. So this is the biggest. Then the second biggest is this. So I should rank this 1, I should rank this 2, and then I should rank between this and this. So 909, this is 0, so this is bigger. So this is the third one, this is the fourth one. Okay, so the first one is 0.9 with the dot above. By the way, you should use the original number. You cannot use the converted form. So this is the biggest. Then comma 0. Okay, 99%. And then 0.909 with 2 dots above. And then last. Okay, this is one way to represent descending order. The other way to represent it is some people they can use a big, right? Big means something like this. You can use this. Okay, so sometimes you see that they express in this format. Okay, sometimes you see they express in this format. So you are not correct. And by the way, you know what? Do you know how I get this? The most important thing is you need to know how to get it. Okay. Do you know how to get it by now? Okay. So number one, descending, big to small. The other one, the opposite of it is called ascending. Ascending means small to big. Okay. Always convert them to the decimal form. Once you have the decimal form, align them. Because only when you align them, align them means this. Okay. Align them digit by digit. So it's easy for you to compare later on. If you don't align them, right, it's very hard for you to see, especially when they are so close to each other. Clear or not? Okay. So please do it this way, and then you minimize your chances of making mistakes. Okay. Next, last one. Is it last? No, not yet. 5. Question 5. I hope you can read the question. If not, I will assist you. You finish ABC first, then one shot I will help you go through. Last one, C. Okay, so let's look at it together. So which country was the coldest? Okay, coldest, so means the more negative it is the coldest. All right. So Greenland. Okay. So basically you need to write Greenland. Next, what was the difference? So how do you find difference? So difference is equal to the bigger number minus the smaller number, or bigger value minus the smaller value. So in this case, right, between Hong Kong and Norway, 14 is bigger. Then you minus the Norway, so minus 10. So you don't need to put a unit during the calculation. Okay, over here, right, even though it's 1 mark, right, you need to show the working. Even though here is 1 mark, you need to show the working. No working, they have the right to penalize you. So always remember, show the working. Show workings whenever possible. If you don't show working, they have the right to penalize you, and you don't want to get penalized, right? So remember, difference is bigger value minus the smaller value. In this case, 14 minus plus, so it's 24. So it's 24 degrees Celsius. Okay, always remember unit. All right. Next, what was the average? So how do you find average? How do you find average? Write down the formula first. Average is equal to total divided by number of items. So total, just add all these up. So you sum it up. Okay, you sum it up. So you use the sum. Total number of item 1, 2, 3, 4. So okay, you have to figure it out. So I can do it here to sum it up. I can use my calculator. So I have 30 minus 22 and minus 10, and then plus 14. Then I divide by 4. Yes, so it's 3 degrees Celsius. Okay, yeah, good. Next, yeah, last question. Can you clear your handwriting? I will pass this question to you first. Capacity of 1 cup. Let me see. Bottle water is this. I'm going to pour this water bottle in 7 cups. So how many full cup can Peter? Oh yeah. So okay. So you are right. So 330 divided by 7. So what do you get? Can you help me out? What do you get? Give me in mixed number. Hello. Yeah. 47. Okay, good. So basically you get 47 full cup and then 17 left. A lot of students think that, oh, I get 47 full cups with 17 left. Okay, so I think for this question, I think okay, I would say you are, I mean, your question is valid. This question is valid. Okay, it's good that you asked this question, but let me double check the question first. Let's see if this is the question, or it has more info. Okay, let me just double check. Okay, good. So for this question, it's valid you ask this question. So what you are trying to say is, okay, so I have 7 cups. 1, 2, 3. Can you erase your handwriting first, please? 1, 2, 3, 4, 5, 6, 7. So what you are trying to say is, okay, then I just give 47, 17 into each of these. Okay, I think it's valid. You ask this question is valid. Okay, but I think the question wants you to find out how many full cups can Peter pour into. So I think the question kind of like wants you to find out, okay, 47, 47, 47, 47, 47, and then how much is left? Yes. Okay, so if you have 47 into 7 of them, so 47 times 7, so you will get 7 times 7 is 49. So 4, 7, 28, 28, 4 is 32, so it's 30, yeah, 329. So you will have after putting 47 into each cup, right? Then you will have 330 milliliter minus the 329 equals to 1 milliliter left. Okay. Yes. Okay. So a lot of students, they say they have 1/7 left, which is not right. Not 1/7 left. It should be 1 milliliter left. Okay. So like for example, you have $7. Okay, you have $7. So you give $7 to 6 people. Okay. Then how much is left? Okay. Let's say so for like probably you can say, okay, 7/6. So is 1/6, right? So you can give people $1 and 1/6, you know, that kind of thing. But in Singapore, or I think in the world, normally you don't have this. I mean, 1/6 is how much? Huh? Let me just calculate it quickly. 1/6. Okay, you don't have 0.166, you know, your all those. Am I right? So basically, right, I think like, okay, the way to do this question is this. Remember the approach. Okay, the most important thing is not so much about the answer, but the approach. So you have $7, you have 6 people. So what you do is 1, 2, 3, 4, 5, 6. So each one $1. And then don't look at, okay, when you use your calculator, right, you will end up with this. When you use your calculator, you will end up with 1 and 1/6. Okay, then probably you think that, oh, so everyone will get $1. Everyone will get $1. And therefore 1/6 is left. $1/6 left. By the way, is this statement correct or not? No, correct. This statement is not right. Okay, so the way to do this question is, once you see this whole number here, right? You don't try to split it. Oh, this is $1, and then this is $1.06. No. Okay, no. Don't look at it this way. Don't look at it this way. You should look at it how. So you just focus on $1 is distributed to everybody. So you get 1, 2, 3, 4, 5, 6. So basically, once you have distributed $1 to 6 people, you have used up $6. So once you use $6 up, then compare your 6 to this total. So you have $1 left. Are you clear? So it's not 1/6 is left. Okay, it's not 1/6 is left. Okay, a lot of students, they make this mistake. Okay, they try to just say, oh, $1 is distributed, so 1/6 is left. No. Okay, in this case, should be $1 is distributed and $1 is left by using this. Okay, so similarly above, okay, 47 into 7 of them, and then after you use 47, 7 times 47, you will get 329, and then you compare your 329 to the total, which is 330, so you have 1 milliliter left. You don't go and split like, oh, I get this. So once you get this, you'll get 47, 1/7. You don't go and split it. Oh, 47 is distributed, and then 1/7 is left. Okay, this concept is very wrong. Okay, this concept is very wrong. Okay, so I just want you to bear in mind you don't make this mistake. Okay, I think we have missed out the first page. Yeah, we missed out this page. So we still have 1, 2, 3 more questions to go. Yeah. Okay, I think this question we have done it right from your school. I mean, you can attempt this, yes, as a revision. Okay, 3 more questions to go. So I will pass this question to you first. There might be more than one possible answers. The pink one here first. Oh, straight away is part B already. Okay, good. So your answer is 9 and 15. Okay, let's look at it together. So I can this is okay. So you can actually treat about 2. This is called prime factorization. So you do it this way, right? It's called prime factorization. In case you don't know, okay, prime factorization. In case you see prime factorization in index notation. So in case you see this word and you don't understand, so basically what they want you to do is they want you to do this, okay? And then this is 3 times 5. Okay, so they say the highest, okay, Hcf, so must be shared, right? So I only see a 3 shared, so it's 3. So I choose the lowest power for Hcf. So Hcf is this, okay, good. And then the lowest common multiple. So for lowest common multiple, it must be all factors. And then for all factors, must choose the highest power because the power is always opposite to the L. Okay, so I see 3 and 5 with a times, not plus, times, and then you choose the highest power. So this will give you 45. Okay, good. So 9 and 15 possible. Okay, good. Next, this question. Yeah, this question is a very common question. So yeah, try it out. I'm not sure. We can look at it together. Yep. Okay, good. So, okay. So, for the prime factorization, right? Just now you show your working. Remember to show your working. If not, you get penalized. So just now you show your working, the factorization. So a prime factorization. Yeah. What's this? You need two answers. Okay, good. Okay, let's look at it together. So for the prime factorization, right? Let's say if you're given minute, so there's seconds. Okay, let's look at it later on. So for the prime factorization, what I suggest is, okay, then you should label like this. Is this the hour? So, you are talking about 5 hour, 5 o'clock, 56 minutes and 12 seconds. Are you saying that? You want to represent the time, then you should use this, right? Okay, but never mind. Let's look at it together. So, I was talking about prime factorization. Okay, can you just erase your yes? I don't know where you get your yes from. Okay, erase your yes first. Okay, good. So just now we talk about prime factorization. So let's say if you are given 25, right? So I think it's better for you to write down the first few prime numbers in case you forget. Okay, so always write down the first few. So once you write down these first few prime numbers, then whenever you need to do prime factorization, you always refer to this. So let's say if you are given a paper, so this is your paper. Let's say this is your paper, right? You have question, all these questions, you have all these questions, right? And you know that you need to do a lot of prime factorization. So at the start, okay, of course, you need to wait for your teacher to tell you you can start. Then you just write down the first few prime factors. Okay, so that you will not forget. Well, sometimes students they I don't know why they just somehow make mistake somehow. Okay, so these are the first few prime numbers. Okay, one is not a prime number. Okay, so you always, so when you do the prime factorization, example 1, 2, 6, so you always start with the 2 first. If the 2 cannot, then 3. So 2, 63. So 2 cannot, 3. So it's 21. So 2 cannot, 3, 7. Okay, good. So 7 is a prime number. I can stop. But according to your school, right, you need to do until you get 1, right? Okay, which I don't think is necessary, but you can. Okay, which I don't think necessary. So I will just stop at a prime number. So once I stop at this, I can actually write down my prime factorization is 2, 3 to the power of 2, and then 7 in index notation. Are you clear? So you must read the question, whether they want you to put in index notation or they want you to put answer. Okay, it's important. This is index notation. This is answer. So depends what they ask. Okay, so bear in mind. Next, for this question, so you have your 6 seconds. So 6 seconds is 2 times 3. This is 8, so it's 2 to the power of 3. And then 9, this is 3 to the power of 2. So you put it separately. Okay, so for this question, okay, I'm not sure whether they want me to give the LCM or HCF. So you can, so there are questions that you can't decide, like, oh, what they're asking. Are they asking me for the LCM or are they asking me for the HCF? So I think it's good that you can try both. Then later when you get the answer, you reason out yourself. Because sometimes some questions are very tricky. You don't know what they're asking also. So just get the answer out first. So for HCF, the tooltip is shared factors. And then this is highest, right? So it's lowest power. So shared factor, I see 2 only. No shared factor. So there is no HCF for this case. No shared, right? Can you see there is no shared, right? This one has a 2. This also has a 2, but this one does not have a 2. So they have no shared factor. So HCF gone. So for this case, there is no HCF. Are you clear? So you are writing something. So you want to ask a question? 1， 什么是 1？ okay 啦。Okay, if you tell me the highest common factor is 1, but is 1 a prime number or not? Okay lah, you can say 1 but 1 is not a prime number, right? For HCF, right? So what I'm trying to say is, let's say I have 12. Can you put 1 here? You cannot, right? Because 1 is not a prime number. You always start with a prime number, right? That's why it's called prime factorization, right? But of course, I agree with you. 1 is the 1 is a common factor, but when it comes to prime factorization, I think this one somehow contradicts. Okay, but good that you realize 1 is a common factor, okay? Yeah, but somehow it contradicts the this prime factorization. Okay, good. So in this case, right, in a sense that they have no common highest common multiple, highest common factor. Yeah, they don't have that unless you say 1 is the one. So I have given you a question that has no HCF. Okay, unless you are talking about 1. Yeah. Okay, good. So that means this question wants you to find LCM. Okay, so how do you find LCM? So must be all factors. So I see 2 and 3. Okay, 2 and 3. And then I need to choose for lowest common multiple L, right? So I need to choose the highest power. So the highest power, 1 here, 3 here. So I need to choose 3. So 2 here, 1 here, I need to choose 2. So this is 8. Then this is 3 to the power of 2 is 9. So it'll be 72, right? So it should be 72 seconds later, right? So 72 seconds is 1 minute and 12 seconds. Okay, good. So please get your representation of time correct. So I think you should represent it this way. Okay. Yeah, AM. Okay. All right. Next, determine the time when the 3 lights will light up together at the same time. Okay, good. So this is the next light up moment. Okay, good. Okay, last question. Question 5. Can you erase your handwriting so you can do it? So 2 marks, 2 marks you must show working. No working, wrong, or penalized. 1 mark. There is no half mark. There is no half mark. Strictly speaking, there is no half mark. So it's either -1 or I mean it's either a deduction of 1 mark or deduction of 0. They don't give you half mark. Okay, good. So like I say, for this question, I don't know what I'm not sure whether I should go for the LCM or HCF. Let's assume I don't know first. Let's assume I don't know. Okay. So if I don't know, I work out both. Okay. So before I work out LCM and HCF, right, the step you need to show. Yeah. So now I'm teaching you how you should show your step so that you get full marks, not just this is 1 mark only. The answer is 1 mark. So in order to show your working, the working you should show is this. You prime factorization 3 of this first. So 180. So 90, 245, 5, 9, 3, 3. Okay, good. I will stop at prime number. Next, 240, 2, 120, Of course, you don't make mistake here now for the prime factorization. So 3, 10, 2, 5. Okay, prime number, stop. 300. 2, 150, 2, 75, 5, 15, 3, 5. Okay, good. So I have gotten the prime factorization already. Now let me get it to, let me just put it nicely. I have 2 2s, I have 3 2s, I have 1 5 for 180. 240, I have 3 2s, 4 2s. And then 1, 2, 3, 4. So it's 5 and 3. And for 300, I have how many? 1, 2, okay, 2, 2, 1, 3, and then 2, 5. Okay, so like I say, you can always work backward. Work backward means see if you can get back the original. Okay, if you can get back, that means you can mark yourself correct already before your marker marks you. Okay, so always check. So you have some options to check in set 1. Okay, so like I say, I'm not sure whether I should go for the LCM or HCF. Let me just get the HCF out. Let me get the HCF out and the LCM out. So for HCF is shared and then lowest power. I always remind you these 2 tips. Hopefully tomorrow you remember. Shared means I see 2, I see 3, I see 5. So it's 2, 3, 5. So for highest common factor, I need to choose the lowest power. H here, low here. So lowest power, 2, 4, 2, I choose 2. 2, 1, 1, I choose 1. Lowest, yes. 1, 1, 2, I choose 1. So it should be 4 times, okay, 4 times 15, so it's 60. Okay, so now I ask myself, 60. So so you have 180 chicken wings, you have 240 sandwich, you have 300 fish ball. So you invite 60 people. So does it make sense? Compare to LCM. Let me find out the LCM also. So LCM is all factors. So I see 2, 3, 5. Okay, 2, 3, 5. I need to choose because it's lowest common. So I need to choose the highest power. So 2, 4, 2, I choose 4. 2, 1, 1, I need to choose 2. 1, 1, 2, I choose 2. So you end up with this is 9, this is 25, this is 60. So 16 times this, 400. 400 times this, 3600. Like I say, please use a calculator. Okay, let me use a calculator. Don't try to use mental, okay? I don't trust myself much also. I don't trust my brain, especially when it's already at almost close to 7 p.m. Okay, 3600. Okay, good. So now you have the LCM, you have the HCF. So LCM is 3600. HCF is 60. So let's say you make a mistake. You go and find out LCM instead of HCF. Ask yourself, you go and invite 3600 people. Does it make sense or not? Let's say you choose the wrong one. Does it make sense? You go and invite 3600 guests while you only have 180 chicken wings, 240 and 300. Even you add up all these, you will end up with what? You end up with 720. Your 720, you can't fit 3600. Okay, you can, but like point something, right? So what I'm trying to show you here is you can make a mistake, meaning like you can misjudge. Okay, you can misjudge and find the LCM. But somehow once you get your LCM right, you can ask yourself, does it make sense? It doesn't make sense. So when it doesn't make sense, then you do the switch to HCF. Once you get the HCF, it makes complete sense. Are you clear? Are you clear? Okay, so what I'm trying to say, right? I think you should observe one very important thing in set 1 is you can make mistake, but you can self-correct when you make mistakes. Or you can somehow check the answer, whether this answer makes sense or not. I mean on the spot, right? So I have figured out LCM. I misjudged the question. I go ahead and find LCM. and I realized, hey, LCM doesn't make sense. So if LCM doesn't make sense, then HCF has to make sense, right? So the working you need to show is this part. So you need to show this part, okay? And then for HCF, right, you need to show this part. And then of course, then you get the answer 60. Okay, so all these three things in the circles, or this is not a circle, oval, this oval circles. So what you need to present in order to get 2 marks. Are you clear? How do you get 2 marks? If you don't show them, you get penalized. All right. So once you get 60 guests, right, then of course, how many sandwiches are allocated? So you just use this 240, you divide by 60, so you get 4, right? Okay. Okay. So okay lah. So of course you need to how many sandwiches? So it's 4 sandwiches. If you need to answer the question, they talk about statements, right? Yeah. The other time I think I look at your. I'm not sure if I look at yours or I look at somebody else. So if you need to answer this, then you must say 4 sandwiches. Okay. Then they penalize you for not writing the sandwiches. Is it your work or somebody else? So if you put 4 wrong, because they want you to put the statements. Are you clear? Is it you or not? Is it from you or from somebody else? The sandwiches you must answer with units. Okay? Are you clear? Are you clear or not? Hello? No answer? Nothing? Okay, good. Can you help me clear your this handwriting? Okay, good. So just now, I think there are some more questions here, which okay, by the way, this revision questions we have gone through already. Basically, I just cherry pick the questions from cherry pick 3 questions. I mean, cherry pick the questions from these 1, 2, 3 PDFs. And by the way, these PDFs are 2019, 2020, and 2021 common test 1 from Yuxing, which is Wednesday. For her tomorrow, Wednesday, yes. Okay, so yours is tomorrow. So I think we have solved this, like the temperature one. And then of course, I don't think we have talked about the number line. I think it's good that we look at the number line as well, in case you have forgotten. So how do you do question 2? I will pass to you question 2. They say they want prime number, by the way. And by the way, they say inclusive. Inclusive means 11 also included, 20 is also included. But of course, you need to decide whether 11 is also the, okay? So 11, ask yourself, 1 times 11, so 1 in itself, or there are more. So I cannot find more already, so this is 1. This one I can see 2 and 6, so cannot. This one 1 and 13. Anything else? No more already. This one 2, 7 I can see, so 不是. 15, 3 times 5, 不是. This one 2, 6, 2, 8, sorry, cannot. So this one can. 1 times 17. So this one 3, 6, cannot. This one 1 times 19 only. This one 2 times 10. So yeah, good. So that's how you figure out. Okay, that's how you figure out. Okay, for number line. Yeah. So for questions like this, once again, don't do these questions straight away. Alright, don't do these questions straight away. Do you still remember the map? Can you draw the map here? Real numbers. Get the map out, then continue. If your map is right, this question most likely is right. By the way, this question is easier, but get the map out first. Can you continue the map here for me? I just want to make sure. Don't refer, don't refer. Try to write the map out, okay, from your memory. See if you can remember. Don't refer first. Try. So you start with real numbers, then left, right. What do you have? Don't do the question first. Get the map out first. Do you remember now? Rational. Then over there is irrational. Okay, very good. Okay, but irrational. So you need to give yourself some example of irrational numbers. At least two. Pi is one of them. Yes. Then the other one, give at least two examples. So later you can actually. Yeah. So pi is one of them. No, this one is stop. 3.1415962 is stop at 2. So it's not non-stop, right? Am I right? Right? Square root. This is a fraction. This fraction shouldn't be in irrational. Come on. Fraction should be here. Under rational is integers and fraction. Okay? You see, you have to be very careful. Fraction is under rational. You don't need to square root pi. You square root 5 is also okay. Give yourself something different. All right, give yourself something different. Okay, good. Oh, good that we do this exercise. Later you assume 22/7 is irrational. Oh, GG tomorrow. Okay, good. Come to rational. You see, I help you out already. Integer and fraction. Okay, can I ask you, what about this 0.9 dot? They are rational or irrational? This one. Why? Okay, hold on. Okay, maybe I don't give you 0.9. Let me give you something else. Good that we have this discussion. Let's have 2 over what is 2 over 3? Can you tell me 2 over 3 in decimal number? Very good. So it's 0.6 dot, right? 0.6 dot, right? So then 0.9 dot compared to 0.6 dot above, I hope you can see that they are different value but similar fraction. Okay, in similar fraction. Then can I ask you, 0.6 dot is under rational or irrational? What do you think? Correct. So if they give you this 0.6 dot, right, you can somehow see that 0.6 dot is 2/3. So 2/3 is a fraction. So you should put 0.6 dot here, not irrational. Okay. So now 0.9 dot. So what do you think? Is it irrational or rational? It's actually under rational. Okay. By the way, the irrational number should be non-stop and different. Over here, 0.9 is 99999. So you see a pattern, right? It's always 9, right? For irrational, is 0.985, 2, or 562, like you don't see a pattern at all. So are you clear? Are you clear? So if you want to give yourself a map, once again, can you get rid of your handwriting first? Okay, so the map will be, so real, then you have irrare, so that's short form, rare numbers, irrational numbers. So the example you give yourself is square root 5 and then pi. Okay, and then for rational, you give yourself integer, fraction, and of course, probably you can give yourself this. So fraction is 2/3. By the way, you can get this. I mean 0.9 dot, right, is similar to 0.6 dot. So that's how I judge 0.9 dot is rational. So integer, you split to positive in, and then 0, and then negative in. Okay, so positive in is called what? Whole number, right? Okay, then of course you have your natural number. Natural number. Can you go back to your notes? They say what? 1 is a natural number or not natural number? That one I cannot remember. Yeah, natural number with 1 or without the 1. I last time is natural number versus whole number. So whole number is 1, 2, 3, 4, you know, on and on, right? Then natural number, which one is unnatural? Unnaturally, okay, count from 1. So 1 is natural or not natural? So 1 is natural. Okay, good. You better refer to your notes. I kind of like can't remember this definition, but I remember all this. Are you clear? Okay, good. Okay, so please remember this tomorrow. It's very important. Okay, number line done, and then the map done, and then of course the rest. Let's see, anything interesting or not. Okay, I've gone through this 7 with you already. This jetty one is the same thing. 8 minutes, 12 minutes, 15 minutes. Just now we talked about 6. I think 6, 8, 9 seconds. So this one we have gone through it. This one, question 9. Question 9 is very tricky. Okay, why? Because they say he ate 1 orange flavor. So 1 orange flavor is gone. So it's no longer 109, it's 108. And then they say 1 cola. So no longer 85, so it's 84. Okay, okay, good. Then how do you do this question? Okay, good. Yeah. So I'm not going to ask you to do this HCF because it's so simple. By the way, let's say if you get your HCF, let's say your HCF end up with some numbers, you can always test, right? Ask yourself whether this makes sense or not. If it does not make sense, then you should switch your strategy to LCM. Okay? So if you somehow you misjudge, you go and do LCM, and then ask yourself, is your LCM reasonable, or does it make sense? Okay, if it not make sense, then switch. Okay, so either one should give you the answer. But anyway, before you decide, always, so over here is 120, over here is 108, over here is 84. Always do the prime factorization. Okay, this is always the step 1. All right, this is always the step 1. Okay, I think there is one more question which I want to go through with you so that we have covered enough and you should be ready for tomorrow. Let me get the question. Let me get that question out. Over here. Over here, not very interesting for me. Okay, so I think it should be 2019. There is one more question. One particular type of question. Can you erase your handwriting first? Yeah, thank you. This one, estimate. This one. So how do you estimate? So square root 80. If you go and use your calculator, you end up with like something non-stop because it's irrational. We just talked about it, right? So you need to find a close approximation. So square root 81. So you end up with 9. By the way, this is the working you show. So for this one, cube root 65. I think you get this is also irrational, I guess. So what is the closest you can get a whole number? 64. So you end up with 4. So this will give you 9 approximation. This will give you 4, so 36. Are you clear? So this is the technique of approximation and estimation. We talked about this last time, right? Okay. Are you clear? Without using calculator, so you don't go and use. I mean, you don't. Okay, when they say without using a calculator, right? That means they want to see your manual working. Are you clear or not? When they ask you not to use a calculator, you must give working. Means if no working, they assume you use a calculator. So in another way, they also don't want you to give the exact. So means they don't want you to use your calculator and give the exact number, which is non-stop. Okay, if you give the exact answer, wrong. Okay. One more question. Okay, something like this. They have this. Let's say you have this 2 to the power of 3 times 5 to the power of 4, then 7 to the power of 2, and then they say times a k such that is divisible by 2 to the power of 3, and then what? 5 to the power of 3, then 7 to the power of 1. Yeah, something like that. Or times 11. So what is the smallest k? What is the smallest k such that is divisible? So you should be able to do it, right? How? You know how to do this? Let's say 2 to the power of 4. You know how to do it? Okay, I'll let you attempt first. I think it's from your side, this question. What's your answer? Eleven square. The answer is 11 square. Okay, that means you don't seem to know how to do this question. Okay, good. Never mind. Huh? You are wrong. Okay, good. So you want to reattempt? 11 square times 2. Okay, good. Let's look at it together. So, okay, I think the question, right? The question for this is what you need to do is you just need to compare this one and this one. So I think you can see that, okay, 2 to the power of 3 divided by 2 to the power of 4, I think you end up with fraction, not a whole number. So times means give. So it means you need to give what? Ask yourself, do you need to give a 2? I think so. Give it a 2. Because only when you give it a 2, 2 to the power of 4 divided by 2 to the power of 4, you get 1. Okay, good. Divisible. For this one, do you need to give? No need, because 5 to the power of 4, 5 to the power of 3 is good enough. No need to give. Okay, you end up with 5. So no need. For this one, yeah, so 7 to the power of 2 over 7, good enough. 不用. So now for the 11, I think you need to give it an 11. So it should be 2 times 11 is 22. Oh, by the way, this question is so clear cut until you don't have to. Okay, I think the question is not so straightforward. Okay, can you do me a favor? 2 times 3 times 5 to the power of 4 times 7 to the power of 2. What's the answer here? Can you give me the answer? Quick, I need to get this out as well. Okay, it's 2 4 5 0 0 0 3个. Okay, good, 3个. Okay, what about this? 2 to the power of 4, 5 to the power of 3 times 7 times 11. Yes. What about this? Let me tell you how they will phrase the question. Well, later you see the question, you don't know what they're asking, sometimes. Okay, very good. Thank you. So you have this 1540. How many zero? 3. Okay, good. I'm surprised. This one is smaller than this one. You want to double check? I just want to, because this one is smaller than the above. I'm surprised. You want to double check? I'm not saying you are wrong, but I'm quite puzzled. So can you help me out? Double check again. Double check the two answers here. Well, I'm checking it as well. Okay, good. This one is correct. Just let me double check the first one. If it is, it is. Yeah. Okay, good. 可以。来 So, okay, how this question will be phrased is this. So you will say, let's say 245000 times a k. Okay. So the question will be this. What is the smallest k such that 245 sorry 摸嚟 TD 呢笨重喎，咪慢啲都得嘛。Okay, so what is the smallest k such that 245,000 times the k is a multiple of 154000? So this is the question they will give you. And if they ask you this question, right, this is a multiple of this. What is the meaning of this? So that means 245000 you times a k is a multiple. Is a multiple means you divide. So when you give it into this format, right? So your this 245000 you replace with this 2 to the power of 3, 5 to the power of 4, 7 to the power of 2 times a k. And then you get your 15400 into the prime factorization as well. So can you see that? Can you see? You will get what we did just now. So you need a 2 because times k means you give, right? Times k means give. So you need to give a 2. Okay, and then here 5 can, 7 can, no need. So you need another 11. So your k is 22, smallest. Are you clear? Are you clear that this kind of question, actually what they want is this? What if I switch? Let's say I do a switch. Instead of this, is 15400k. It's a multiple of 245,000. So you switch, you switch, you also switch. So instead of this, you put the 154 above, and you put the down. Okay, you put the 245 below. Then you will see that 2 can already, no need, because 24 divided by 23, no need 2. 5354, you need a 5. Very good. Need a 7. Very good. Do you need 11? 不用. So it's 35. Okay, if they ask for the answer, it's 35. Are you clear? Are you clear? So if they switch the k here, how is going to, let's say you need to use this divided by this k. How is it going to affect the answer? So the k is actually below, right? K below means divide. You divide by k means you remove. Okay. Let's try this remove one. So I'm actually giving you a few variations how the question can be. Can you remove your handwriting? Yeah, thank you. So I'm giving you a few variations just to make sure that you're covered. Okay. So 1540. Okay, of course the question will change. So what I'm trying to say is, what if you end up with 154,000 divided by 245,000, and then you divide the k is below. Okay, so you just do it this way. This is 2 to the power of 3, 5 to the power of 4, 7 to the power of 2 times a k. So over here, even though it's times, right? But in order to over here, for this question is actually divide because k is below denominator. So in this case, it's actually you divide by a k. Even though here is times, it's not times, it's divide. So you just this and this. Do you need to divide or not? No need, because it's can already. No need to divide. Because this one is already good enough. Right? So for this one, this is 5 to the power of 3. So this is 5 to the power of 4. So cannot. So you don't want to increase it, right? Do you want to increase it? Oh, by the way, it doesn't make sense that if you put a times k here, because when you divide by k here, right, you need to give. Okay, by the way, when you times a k here, right, you give more to the denominator. And in this case, your denominator is already more, so you don't need to give more. So that's why this question won't make sense. So generally, I think they will ask you for k above in the numerator. Are you clear? Are you clear? So in fact, I try to force my way in. I will realize the question won't make sense. So that's the beauty of step 1. Okay, you can make mistake, but it won't make sense. So once it won't make sense, then you know that you shouldn't proceed. Are you clear? Okay, good. I think we have a very fruitful and very good lesson today. And then with this revision, I think you are more than ready for your exam tomorrow. Okay? Can? If not, then we can actually end the lesson here. Okay, see you. Bye-bye.